Greetings, name's Phuoc, and I will represent my team is Tran to talk about the way that we handle our vulnerabilities that we scan out from Zap. Here's these vulnerabilities. He, I mean the alerts that we have scanned out from Zap, and I will handle the one is absence of anti-CSRF tokens, buffer overflow, cookie without SameSite attribute, as well as how we get the SSL certificate. First, I will talk about the CSRF related things. Zap have told us that we get some alert that we may get a cost side for attack, and I've tried it with I've tried a simple page that we will redirect to our website and make an action that we will add a product to our cart. So let's log in our account. Let's check the card to make sure that it is empty. Here we go. The card is empty, and let's hit the button to add a product to cart. You can see that it's redirected directly to our customer account and adding a cart. Let's reload this page, make sure that it added successfully. So here, so we point out that Zap had right, and we continue to fix it. This happened because two problems. First, we haven't set the CSRF and the anti-CSRF token, and secondly, we haven't set anything that related to our cookie that the outside web can make use of it. Here we can see the cookies entered. The value of securing SameSite are empty. Next, I will talk about the way that we create the CSRF token and save it in, apply it to our project there. I have write a new method, which a new class, which is CSRF token managers, and it have four basics method, which are CSRF token generator, so we can create the CSRF tokens, the store CSRF token method, so we can add it to this section. Get CSRF token. This is where we get the token from the section, and a method to check if the CSRF token is valid. Let's dip into each one. Here we use an algorithm that we reference from the G series OWASP. Is the signed double submit cookie. The main idea of this algorithm is we use three values, which are secret, session ID, and random value. We will combine two values, which is secret and session. The session ID and the random value separate by the symbol. Then we create a message. After that, we will encrypt it using SSL 2256 by using the key the secret. After that, we combine it again. The first part is the HMark encrypted message, and the after one is the raw message. Then put it into the cookie. Everything is the same, but when we use the secret is a hard code, and we create the HMark. Then a different things we will set into section instead of put into cookie, because here we can easily to manage and monitor it. Another value that I want to talk about is the expiration time. Here we set it is 15 minutes for default. Let's move to the check token, the checks method. We will get the CSRF token from the request, then we separate it by the dot symbol. We can see that the first part is the H mark, and the after one is the message. Here we create it by combine H mark dot message. Then we will try to we will try to encrypt the message again with our secret. The client will not know the secret. And we have the recreated HMark, and we compile it with the original HMark that comes with the request. And here's the method that we will create the HMark. Then we encrypt our message by using the secret. Another things I want to talk about is about the guest AF token. It will return the token if the expiration time is still valid. Then, if not, it will create another one and reset the expiration. Next up is we will apply it into our server. I put an comparisons here that will check whether the CSRF token is valid. If it is, then we will continue to work with our action. Otherwise, it will come back to the home.tsp page. After complete all the things, we will recreate the CSRF token to make sure it's different from session. And after that, we will put it into some other authentication related action, which are action like and the view card and the change passwords, or we have making an order, etc. And we will put it into the form. Here's our demonstration. Let's see the page that we have fixed it. Let's try to log in. And hit the button card. You can see the product is still there, and we try to delete it. You can see here's a parameter name called CSRF token is included. And what if I click on the card another time? You can see that it's different because it changed from session. Then I try to attack it from the other page. You can see it's redirect directly into the home page and nothing happened because the action does not include the CSRF token with it. About the SameSite cookie attribute, here we have found out that the SameSite cookie attribute can be easily modified by editing the context.html of the Tomcat server, which is located in the Tomcat, and go to here. You can see the context.xml. Then we put a null tag, which is the cookie procedure, and SameSite cookies is Lux. The SameSite cookies have three values, which are Lux, none, and strict. None is nothing, and Lux, we will have the possibility to access it from the other page, as I have demonstration in the previous alert vulnerabilities, that we can access it from the other page. Here you can see the cookies are the same, EE233, etc. Yeah, because the cookie is set to Lux, it can be accessed from the other page. What if I change it to strict? And we open it. Here, login successfully. Here, just try to attack again. Hit the button Africa, and you can see it redirect into the login page because the cookie value is set to string and it's not allow other page make use of it as lax. You can log in with the use the cookie. When the cookie is set to string and we accept it from the other page, this will be replaced, and we have to log in again. In our page, we will use the strict value because in our application we don't have anything that related to the outside page, so we need to use the lax value. Here you may wonder why we have only changed the SameSite cookie attribute, but we get the HTTP only and secure flag is on. It is because we have changed the protocol to HTTPS. You can see that the local hotspot is also changing. We apply SSL to our project then. Because our project is still the development phase, we cannot use the certificate from a third party. So here we create the certificate by ourselves, and we are not a reliable CA or certificate authenticator. So the browser will mark us the not secure, but overall we still can use the HTTPS for the secure cookie. So here we're using a command named key tool, which is a key and certificate manager come with the Java development kit. So we can create a key pair. Here we have a parameter called gen key, which represents as generate key. So we create a key pair. Next is about the key -key ALG, which is a key algorithm. Here we will using RSA to create a public key and a private key. If we have all know about the TLS transport protocol, we will need to pair a key pair which is a public key and a private key. Next is the hyphen alias is just the name of key, the certificate, and about the key store is the location that we will save the key files. If we not specified it, it will create in where you open the command line. Then about the validity is the existing days of your certificate, and we're using 90 for default and the key size inside of the key. Let's move to create it. Okay, I have create a file, a key store file before, so I will create a new one by open terminal and type. Okay, done. So here we will need to input a bunch of information. Firstly, about the key store password. I will use it is group 123 then. Yes. Okay. A little bit. So we need to input the key password one more time. This is the file 102 is created. Next, we have to specify it in the Tomcat server with the server.xml, which is located in config. Here we can see the server.xml, and we will specify a new connector, which port A443 with max grid, scheme, secure. Here we can copy the TLS template example. Here they have created for us, then we modify it. Here the scheme is HTTPS, set security true, SSL enable. Then the key store here is the key store file location. Group 103 key store password is group 123, and about the key alias. So we specify a TMS protocol in the server.xml. Another thing that you need to notice is you have to create a security constraint in the web XML of our application. Here, the web resource collection is the range of the page that we will apply HTTPS. And here we specify the slash star, which means we apply to all of our web and set the transport guarantees into confidential. So it will require HTTPS for all of the page. Here, transport guarantees have three values which are non-confidential and integrity. This will prevent the data in the transport from being edited. So here we need to modify a little thing here that will specify the HTTPS port in the Tomcat server so that we will run it. Yeah, we can see it specify a new certificate and told that the server certificate is not trusted because we are not a valid CA. Not a reliable one as the third party, so it will just notification, accept it. Here you can see we access it using HTTPS in the local host A453 port. You can see the certificate here we have set before. That's all about the SSL certificate. About the buffer flow in Java, about the buffer flow that we accept throughout in our application. Maybe a buffer flow and we tried each one, but nothing seemed to happen. It seemed to change to the web. And you can see it's just go directly to the login page and not any others throughout in the server side. You can see. This is because through our reference on the internet, we found out that overflow usually happen in the language that they see in C++, and because it's easy to override memories in this low-level language. But in high-level language such as Java, it include many mechanisms to prevent the buffer overflow. Um, First is about array limit checking. So it will throw an exception array index out about if the input is out of the limit or out of the mode automate. And secondly, it using automatic memories instead of the hardware. So it will allocate the memories based on the input and remove the trust that not used anymore. And in the string handling, the Java string last intended to be unchanging. Activities that alter string really make new example rather than changing the current item. Through that, we can see that anything that may change the string that will create a new one instead of modify the given one. So Java has its own many mechanisms to prevent pop-up load, so it might not possible to happen in our server, in our website, and that others maybe in a form positive, but we have some mechanism also in our application so that we prevent the overflow or the header size email too large. So we have set the max HTTP header size in the server.xml, which is 40,000 kilobytes, bytes rather than 8 kilobytes in default. And we have set many input validation, such as limit the size, the input in the page visit and about 20 characters, 30, and so that's all about the buffer flow. It's just a positive case in SAP.
Hello, teacher. I will continue first presentations. My tasks include content security policy header not set, cross-domain misconfigurations, and cross-domain JavaScript show file inclusion. First, we will go to CSP header not set. This risk is about CSP. This is an add layer of security that helps to detect and mitigate certain type of attacks, including XSS and data ingestion attack. These attacks are used for everything from data thief to site defacement or distribution of malware. CSP provides a set of standard HTTP headers that allow website owners to declare approved source of content that browser should be allowed to load that page. Cover types are JavaScript, CSS, HTML frames, fonts, image, and invisible objects. Um, in my projects, um, the server does not include any proper CSV header in its response, so browser will not enforce the policy, and this can leave our website vulnerable to certain types of attacks. There are two common ways to implement CSP. First is HTTP header. This is the most common way to implement CSP, and the other is um, through meta tag. About meta tag, we must include this CSP. We will define the CSP in each page of my project. But in there I include it in the header.csv and link this to every page we have. But in our case, the because we are working with a CSV file now, then I would likely need to set the CSV in the HTTP response. So I will create a class, name it CSV filter, and in this code, um, I will check if the response object is an instance of HTTP servlet response, then set the content security policy header to the value of CSP filter dot policy. The CSP policy constant is defined here. This line of code defines CSP for this web application. First is default source self. This is default policy for loading content such as JavaScript, image, CSS, fonts, and here self means only from the same origins as the domain that the page is served from. Source script cell is specified valid source for JavaScript. Image source cell is specified valid source of image. We can reference in the website. In there, we will find very directive that we need to define in CSP, like fast directive, document directive, and navigation directive. Okay, this is about CSP. I will present all the errors that need to be fixed in my project code and scan with the JAP again in the end. About cross-domain configuration. Cross-domain misconfiguration. It is a security issue that occur when an applications allow requests from different domains that it should not trust. This can lead to various attacks such as CSRF or XSS that are leachable. So in there, if the access control allow origin set to there, it means that the server allow any domain that access its resource will allow this effectively disable the same origin policy can lead to potential security risks such as CSRF and data leakage. And but if the access control allow origin not set, And this means that the server has not specified any policy, and this policy will allow different origin from different domain that will access our resource. So in my project, I will set for it. We call it we call for the set header access control allow origin in each response. In in this code, localhost, which means only requests from this origin are allowed to access our resource. It's pretty simple because I just create the CSP filter and we just code continue to our to this class, and the, about cross domain JavaScript short file inclusion. Okay, it's also known as cross domain scripting or cross domain script include. It refers to security vulnerable where a web page includes a JavaScript code or external JavaScript file from a different domain or origins. It's it occurs when a web page include a JavaScript file host on a different domain, and this can happen unintentionally or due to a misconfiguration in the web application. In our project, I I use another JavaScript file. In here, we use another JavaScript file in Outlook. It is unpage.com or Sicon. So I will to mitigate the risk. It's, I recommend you to use sub resource integrity. It is the it means that it will include cryptographic hash of the file in the integrity attribute of the script tag. The browser will only load the file if the hash of the download file match the hash in integrity attribute. So to generate this, we will use a website HRI hash generator. We just need to the copy the domain of the script we use. Then hash is okay. The cross origin attribute is set to anonymous, which means the request for the file is made without sending any user credential. So the if we set to the script like this in every the JavaScript output we are using, that error will be fixed. Okay, we will reload the server and rescan with that to see if we can solve this error. Okay, after apply security for my project code, I take care on three errors. That is CSP header set, cross-domain misconfiguration, and cross-domain JavaScript supply inclusion. This is solved. Uh,
Good day everyone, my name is Xuan Truong and my student ID is Xuan Truong 0101. Today I will be discussing critical web security vulnerabilities, glitching and parameter tampering. Understand these vulnerabilities is essential for securing web applications and protecting user data. And first, part one, I will introduce the click-checking. What is click-checking? Click-checking is malicious technique to trick user into clicking on something different from what they perceive. The attacker creates a deceptive interface that overlays invisible elements over the legitimate web page. When users interact with the visible elements, they unknowingly click on the hidden malicious elements. But how does click-checking work? Uh, the attacker crafts a web page with multiple transparent layers using HTML tags like iframe, frame, and object. The victim accesses this deceptive webpage, typically through a link shared by the attacker. Um, the browser renders the attacker's webpage. When the victim clicks on the appearing elements, they are actually interacting with the hidden elements intended by the attacker. To solve this problem, we use X-frame option. The X-frame options HTTP header is an older standard that can be used to indicate whether or not a browser should be allowed to render a page in a frame, iframe, or object tag. It was designed specifically to help protect against glitching. There are three permitted values for a header. First, I will introduce the value Danny. Uh, the page is meaning the page cannot be displayed in a frame regardless of the site attempting to do so. And the second value is same origin. It's meaning the page can only be displayed in a frame on the same origin as a page itself. And the last is allowed from URI. The page can only be displayed in a frame on the specified origins. Um, Here is the JavaScript filter to prevent glitching by adding a header to every response from the server, specifically the extreme option. To control where your site can be embedded, use the frame ancestor directive. Any similarity or allow from URI that I talk about here. The attacker website has HTML code like this. This website appears to be user interface for logging into the demo for system. The attacker embedded this website in an iframe on his site, including a go to link button that redirects user to an external link when they click. If we don't have any protection in place, user can easily be tricked into clicking on a link and put on a website that looks similar to the website that uh, they are already using, and then users can be scammed out of money or have their account information stolen. You can see go to link, but when I CSS this go to link in under the login, and the user can be click, and we might be have the information stolen. So this is a link that attacker link it. And how to protect them. I first any block or reading of data from pages with frames and iframes. Take set the header. I will set header iframe option then we just do access. It will show refuse to display because it set its frame option to deny, and similar to the first, we will try with same origin only allows reading data from frames and iframes in the same domain. Effect use when you want to website to only be embedded by page of the same domain. This is a safe choice when you want to allow embedding in internal applications, but still want to protect against clickjacking from external sites. And we will add same origin like deny in ahead, and it will show refuse to display because it sets its frame option to same origin. And the last we use allows from URI. The page can read data from the defined URI. For example, we allow from http example.com. Effect used when you want to specifically specify which websites are allowed to embed your website. This is flexible option that give you more specific control over the justice site you are allowed to embed your contents. But right now I will demo for you to understand attacker's web page. This is the attacker web page. I will yes, I have a free iframe that have my clean web page, and I will try it show similar to my web page, and the user can click the link and being stolen the information. But how to prevent this clickjacking? First, I will in my code I will add the filter that have the extreme option deny, because I don't want to anyone can access this web page. Yeah, and I read the web again. And when I click something on web, it will show some link, some Facebook to follow or like, or sometimes we can stolen the we can stolen our information. So we need to care about this, and we need to care. When we set the header extreme option deny, we try again to attack. Yeah, this web page. This is my web page. It's not have a problem, but right now it will set the header extreme option deny, and we try to attack again. Yeah, it will show localhost refuse to connect. When we can view the console, it shows that refuse to display HTTP localhost because it set extreme option to deny. Yeah, and this is my demo to in click checking, and the another the orders value like same origin and allow from URI is the same, and you can try if you is if it's suitable for your project. So you can try some same origin or allow from URI. So this will protect your website to click checking. And right now I will introduce the second vulnerability, that is tampering. First, I will introduce the tampering. The web page parameter tampering attack is based on the manipulation of parameters exchanged between client and server in order to modify application data such as user credential and permissions, price and quantity of products, etc. Usually, this information is stored in cookies hidden from fields or URL query string, and is used to increase application functionality and control. For example, example 1, the parameter modification of form fields can be considered a typical example of a web parameter tampering attack. For example, consider user who can select from form field values, combo box, checkbox, etc. on an application web page. When these values are submitted by the user, they could be acquired and arbitrarily manipulated by an attacker. Example 2. When a web application uses hidden fields to store status information, a malicious user can tamper with the values stored on their browser and change the referred information. For example, an e-commerce shopping site uses hidden fields to refer to its items as follows. Input hidden ID equal 1008, name cost value equal 70. But it can change the value to 60 or 40 or 50 In this example, an attacker can modify the value information of a specific item, thus lowering its cost. Example 3. An attacker can tamper with URI parameter directly. For example, consider the web application that permits a user to select their profile from a call box and debit the account. You can see debit 1000. This guy attacker could tamper with the URL using other values for profile and debit. You can see it changes from 1000 to 2000. Other parameters can be changed, including attribute parameters. In the following example, it's possible to tamper with the status variable and delete a page from the server. You can see exchange the read and to delete the page. You can see the read to delete. And I will introduce the vulnerability. The ZIP application scan and detect parameter errors by checking whether your application properly validates and handles user input parameter. Parameter tampering error occurs when the application does not thoroughly check this parameter, allowing attackers to change the value of the parameters to achieve unwanted purposes, such as unauthorized access, performing malicious actions, activity that is not allowed, or causes an error in the application. Here's how ZIP was able to scan and detect parameter tampering errors in my application. First, a change parameter values. ZIP send HTML requests and to monitor application response. And the third, input validation and checking. ZIP check whether the application adequately validates and checks input parameters. If it is discovered that the input parameter is not properly validated, this might result in a parameter tampering error. And the last, detect unusual behavior. Because in my email controller code, the action parameter is taken directly from the request without thorough testing. This can lead to a parameter tampering error because an attacker can send requests with different action values to change the application behavior. So you can solve the error. An email controller. Because I don't check the action is null or unknown. So after I added proper checks and handling for the action parameter, this error was fixed. So ZIP no longer detects the parameter tampering error. You can see when I edit this code action, I will check this action is different null. So I will add the code. You can see when I fix, I can accept the email page. In short, the parameter tampering error is detected by ZIP because my application does not properly check and validate input parameter. Once you have added these checks, This error is fixed and is no longer detected. This is the testament to the importance of checking and validating user input parameters in protecting application from security vulnerabilities. So that's my uh, presentation for two vulnerabilities. So thank you for your listen.
Hello, my name is Nguyen Thi Tuyet Mai. Today I'd like to present four vulnerable. The first one is vulnerable JS library, and because in our project, our team use moment JS library in the old version. There's a function that's called local that accept the name param and there is no check to see if the name is valid or not, or does it contain special character. It just loads straight up, and hacker can exploit this vulnerability. To fix the vulnerability, we can install the latest library, or we can fix it manually. So if we want to do it manually, the way is pretty simple. We just need to see if the input name is valid or not before loading the file. And the second vulnerability is XLST injection. So this one is actually not a vulnerability. Is like a false positive of Zap, because when Zap request goes to a page that does not exist, it triggers the 404 error, and instead of return the error page telling the customer that there is no page, it actually return the exception error traceback. So to fix, we add 404 page and 500 page, so that when these two error occurs, the customer will be direct to the correct page. The third is X content type option header missing. This vulnerability is due to the server returning a response without X content type option header as code. So the browser will not know what the data is returned is. It could be a JSON, HTML, or an image. To fix it, I will add the header to the response. So here we use many controller, and adding each one manually would take a lot of time. So my solution is I write a filter, and responses before being returned to the client will go through the filter. If you add the header and then go back to the client, you can see it here. And to apply this filter, it must be declared in the web.xml, and we have to declare it here, and then we apply it to all the routes. Now we can go to the website and see if it works. Okay, so we can see that the header is added now to all the requests that was returned from the server. And the last vulnerability is brute force password attack. While checking the code, I saw that my teammate used 1234 as the admin password, and this password is really simple and very easy to guess. So I have added a piece of code to check whether the input password is valid or not. It must have at least 8 characters, at least one word, at least one number, and at least one special character. And also change the password to make it harder for hackers to guess. And this is just a temporary way to prevent hacker, but there could be many more solutions to this. For example, we can apply captcha or rate limit, like 100 requests 1 minute. So, and after that we can block the request from that IP and return 429. Or in some company, people will use VPN and only the connected device could access the admin system. So I have VPN connect to Huawei, and we can try the QC site. We can log in like normally, right? You can see. Now, when we disconnect and okay, so after we disconnect, the login button doesn't work anymore, and even if we try to reload the page, it will keep loading forever. And I think this is a very, very good method, but our project is not large enough to apply this. So